So for everyone that's missing class today, here's briefly what we're going to be doing. All of the formulas that you see up here are derived from what we did yesterday, so the sum or difference formulas. So for example, if we took the sine of theta plus theta, which is 2 theta, and we used the sum or difference formula from yesterday, we would get sine cos plus cos sine. These two are the same exact thing, so we get 2 sine theta cosine theta, which is exactly what we get if we look at this formula right here. So we're going to use these formulas, and I'll give those to you on Friday to do some of these problems. So hopefully it's not as blurry as it looks right now. So this says if sine theta equals 3/5, and it's between pi over 2 and pi. So first we're going to draw a triangle. That's going to be in the second quadrant. Sine's right there. So we have 3, 5. So we should know that's a 3, 4, 5 triangle. So that gives us -4. Now we're just going to use the formula that we have up above to find sine of 2 theta. Sine of 2 theta is the same thing as 2 sine theta cosine theta. So we already know what sine theta is. Sine theta is 3/5. So this is 2 times 3/5. Cosine theta is -4/5. So 2 times 3 times 4 is -24 over 25. If we wanted to do cosine of 2 theta, we have multiple formulas that we could use for this. Cosine of 2 theta has a couple. We have cosine squared minus sine squared, we have 1 minus 2 sine squared, and we have 2 cosine squared minus 1. I would suggest using the one that you have the most information with, so I'm going to use this formula right here. So that's 1 minus 2 sine squared theta, which is 1 minus 2 times 3/5 squared. 3/5 squared is 9/25 times 2, which is 18/25. 25 minus 18 is, let's write that out, 25 over 25 minus 18 over 25. So that gives us positive 7 over 25. There's our answer. So if we zoom out just a little bit, scroll down, we can come up with a formula for the sine of 3 theta. So sine of 3 theta, use what we know, is 2 theta plus theta. So now we're going to use our sum or difference formula. So that's sine cos plus cos sine. So there's our first step. Now, we already know what sine of 2 theta is. We can look up above, we can look at our notes. That's going to be 2 sine cos times cos plus cosine of 2 theta. We can look back up. We see that we have a couple options. So I'm going to choose, since we're working with sines and cosines, I'm going to do cosine squared minus sine squared. So this gives us cosine squared minus sine squared times sine, and this is 2 sine cosine squared plus sine cosine squared minus sine squared. So we can do, this is one formula. We could also factor out a sine from both of these, and that gives us 2 cosine squared plus cosine squared minus sine squared, which we can break that even further down, which is 3 cosine squared minus sine squared, all times sine. There's a bunch of different formulas that we could get. This is just utilizing our formulas that we have above for double angles. So next up we'll do half-angle formulas and just their application. So here are the formulas for half angles. We can derive all of these from double angles and the sum and difference formulas. So if we have sine of alpha over 2, it's plus or minus the square root of 1 minus cosine theta over 2. Cosine is the square root of 1 plus cosine theta of 2, and tangent is a little more complicated. So the plus or minus is determined by what quadrant the original angle is in. So if it's in 1, we have to, all are positive, and we're going to use our all students take calculus to figure out where each trig function is positive. So let's go try some of these. Cosine of 15 is the same as cosine of 30 over 2. So we go to the cosine half-angle formula. That's going to be positive. So it's the square root of 1 plus the cosine of 30 over 2. We know what the cosine of 30 is. It's the square root of 3 over 2. So I have the square root of 1 plus the square root of 3 over 2 over 2. We can leave our answer like that, but I want you to think about what we talked about yesterday, that we found this exact same thing. We're using the sum or difference formula, and we got the square root of 6 minus the square root of 2, or plus the square root of 2 over 4. So if we wanted to use the half-angle formula for sine, it's the square root of 1. This is the same thing as sine of 30 over 2. So we can look at the formula up above. Sine is subtraction. So 1 minus cosine of 30 over 2. So that's the same thing as the square root of 1 minus square root of 3 over 2 over 2. And we'll just leave it as that. Again, what we found yesterday, this is equivalent to the square root of 6 I believe that's what we found yesterday, because that was 60 minus 45 gives us 15. So last bit. If we're given this information, cosine alpha equals negative 3/5, and this is in the third quadrant. So in the third quadrant, only tangent's going to be negative. And let's see if I can erase that. Okay, let's keep this on the screen. And we'll just ignore that for now. So sine of alpha over 2 is the square root of 1 minus a negative 3/5 over 2. If we simplify this down, we get the square root of 1 plus 3/5 over 2, which is 8/5 over 2, which is 4/5, so the square root of 4/5, which is, square root of 4 is 2, so we get 2 root 5 over 5. If I do cosine of alpha over 2, that's the square root of 1 plus the cosine, 1 plus negative 3/5 over 2, which is 5 minus 3, which is 2/5 over 2, which is 1/5. So that is the square root of 5 over 5. And if I do the tangent, the formula is a little different. It's basically the sine over the cosine. So what we found in the first one is 8/5 divided by 2/5, which gives us the square root of 4, which is 2. If we go down to the homework at the bottom, the only thing that I'm asking you to change is 7 to 12 should be 7 to 9. Everything else stays the same, 19 through 23, and one proof, 47.